Okay, showed up slightly late here. What's going on? Seed, soil, fertilizer. Any of the initial seed numbers. What location? I see. What does this mean? Since every case, so I will want an example. Like a fixed number of maps. Probably. Okay. Okay. So what does this mean? Seed number. Desk start. Is C. ranges of seed numbers. Sure. Lowest, okay. There's some way to group these things. Pretty sloppy of me. Start plus size. Slow can this be? Slow. Huh. It seems somewhat challenging. Okay, I get 46. That's good. I see. I just need to like map our whole range through. Looks tricky. Do you know how to solve this? Not really. Okay. So it might cut, or it might not. this is right. That would be cool. Okay. Tough start, especially since I didn't actually start on time. But a reasonable recovery, I guess. Cool problem. Very hard, I think. Yeah, I'm surprised there's such a hard problem so early. So what's going on? Okay, so we're given this input, which has basically a bunch of starting numbers and a bunch of functions, I would say. And so what is the deal here? So like 70, so the starting numbers are 79, 14, 55, and 13. And this function says, let's see, does it do anything interesting? It maps the 48 numbers starting at 50 to starting at 52. So like it increases by 2 the numbers from 50 to 97. And it decreases by a bunch the numbers 98 and 99. Right? It maps 98 to 50 and 99 to 51. So we apply all of these functions. There's like 6 or 7 of them. And then we get some outputs. And then we want the minimum output. So that's part 1. So let's look at that. And also my code is very ugly, so I might try and clean it up a little bit. We will see. Yeah, actually, part 1, interesting. Okay, so first we, so the input was given, separated double by new lines, so split that. We have the actual input numbers, which are special, and then all these functions. And then we can just grab, and I really should have changed these to ints. Grab all the inputs, right? Take off the the seeds colon part. And this is like applying a function. I kind of want to make a class for this actually. I feel like my explanation cleanup is going to be a bit longer than usual because this was a pretty tricky problem. Types, sure, he's going to stop me. So this function has, starts with a list of lines. Sorry. So let's write a class to encapsulate like one of these things. And it can just take the whole string as an input. So times equals, so throw away the name, comment, and then parse everything into tuples of 3 integers, which are desc, source, and size. Okay, so the first thing that we'll need is just applying a function, one of these functions to an integer. This will be enough to solve part 1. So we can go through each of the tuples. And this is, what I wrote sort of when trying to race to solve it, but just sort of clean, I'm mapping it up into a class so that it's clear what's going on. So if the value in question is sort of falls within one of these ranges, then return x plus dest minus source. right? So like the function moves it by this much. And you can see that we map like source itself to test. And if none of those things happen, then we just return the whole function. Or sorry, then we return the original value. That's what it says somewhere. Yeah. If it's not mapped, it corresponds to the same destination. Okay, and that should be enough to solve part 1. So let's see. So just go through all the starting inputs and just try that thing. This does in fact itself, which makes sense. Expected. I did expect you. Generator. Should be that split. Cool. Okay, this gives 262.73516. 262.73516. Excellent. Okay, so that's part 1. We just go through all of the seed values. There's not very many of them, like 10 or something. Just apply each of the functions, and that gives you the final location. Get a list of all the final locations, take them in. And you can see apply is not that complicated either, right? Just like check if you're in the input range, and then map to the corresponding output range. Part 2 makes it actually quite a bit harder, because part 2 gives a lot more inputs. So what it says is, instead of considering each seed one by one, consider the seeds in pairs, giving like a whole range of inputs. So instead of this being 79 and 14, it's actually the 14 numbers starting with 79. And this is a problem because you can see in the inputs that these numbers are huge. So this range represents 100 million seeds. It's too slow to just check them all one by one. So we need to do something smarter, which is consider processing a whole range at once. So that's why instead of just the apply one function, I've written an apply range function, which is going to take a list of ranges. So we're going to treat like whole intervals of numbers as our inputs and outputs. And apply range is going to take a list of intervals and give you back a list of intervals. And then, well, let's see how this is going to work. So, yeah. Surely there's some way of doing this, right? I don't know. This does not seem like readable. Yeah, that's horrible. Is there really not like a nice way of doing this? Okay, I can live with that, I guess. So what this is saying is take every even seed and every odd seed, right? These are the starting numbers, these are the lengths. Pair them together and turn that into a list. So sure. Okay, so this gives us a starting interval, which is, you know, just starting there, that many numbers. I'm handling all my intervals as inclusive on the left, exclusive on the right, which is just the best way of handling intervals, because, I don't know, like when AB equals B minus A, AB plus BC equals AC, it just gives you nice properties like that. Okay, so we need to go through and apply all of our functions. And we are going to use the apply range function, which takes a list of ranges and gives us back a list of ranges. So we're going to have this ever-expanding list of ranges, which could get a little bit complicated, but it's not going to be as complicated. You know, it's not going to be as much work as trying to do all the seeds one by one. It is going to be more complicated, but it's going to be less work for the computer. Okay, so now we have all of our ranges at the end. At the end of the day, we want to know what the minimum location is. Right, here we have a whole bunch of ranges of locations, so that part is not too bad. We can just take the minimum. Right, this gives us sort of the leftmost interval. This gives us a starting point. That is the minimum for this, you know, seed interval. And then we can just print the minimum over all of the intervals. Cool. So now we just need to implement apply range, which fortunately I, you know, basically implemented this function to solve the problem, and I can just copy it over. So for dest source size in self.tuples. This should be it. Let me see if this is right, and then if it is right, I will explain it. It is not. Okay. I think I need a slightly newer version of Python for that to work out for me. It's troubling. But that needs to go there. Okay. This prints out 340-39469. So that's a good sign. That's what I got during the contest. Okay, so how does this apply range function work? So we have our input intervals, and the function is like a list of I don't know, transforms a specific interval. So you can imagine we have, you know, source. So we have our input intervals, which I'm calling start and end. Right? It looks like this. And in the middle here, we have the like interval of interest in this function right now, which is like source end. And this cuts it into 3 pieces, which I might need more space to show, I guess. I'm going to show closed intervals just so they actually sure. Right, so this is sort of a generic, well, okay, this is one case. There's actually a few different cases depending on how the intervals overlap, so it's a bit messy. This is maybe the most interesting case. So we have our input interval, and it's doing something to this part in the middle. And then there's this part before, which is unchanged, and this part after, which is unchanged. So basically, we need to feed all of our input intervals, into these functions, into this function, which is just this list of transformations. And every time you cut the input into 3 pieces, some of which might be empty. So there's a part before, which we can see goes from start to the min of the end and the source. There's the part after, which goes from the max of the source end and the start, right? The max of this and this to the end. And there's the intersection, which goes from the max of the starts to the min of the ends. And despite the fact that I've only drawn the case where like this interval is inside this interval, this is actually correct for all possible sort of orientations of the interval, except that sometimes these things are empty, which is fine. So if before is non-empty, then we need to send the before interval to be processed by all the other tuples in this function. Similarly for after, right? It's not changed by this specific tuple, but it might be changed by something else. And then the intersection is the part that actually is changed by this specific tuple. And the way that it's changed is exactly the way it was changed up here, which is you add dest and you subtract source. And we can just add this, sort of send this directly to the answer. We know that it hit this interval, so we know it's not going to hit any other interval, right? The functions like don't give 2 instructions for the same number. So if we've already like applied the function in a non-trivial way, we can just send that directly to the answer. And then these things we need to like keep trying. So we can keep, do this. So these are the things that we need to like retry. After we're done with this one, we can stick those things back in the like list of things to try, for all the other tuples. After we're done with all of these, we have some stuff that's been transformed and some stuff that like never found a match and stays where it is, and they are both valid output ranges. So just return all of them. Okay, so that was messy. But then the final code is like kind of nice, right? You start with this one interval, you get all of these, output intervals. Potentially there could be a lot, actually. I'm kind of curious. Yeah, okay. It's not actually that big. There's only, but like it could have been big, depending on the inputs. Right, because every like interval could cut everything into 3 pieces, kind of. Probably that's not really possible. Anyway, they're not that big, right? There's only like 46 ranges at the most. And then we just take the min of all of them. So that is day 5. Pretty complicated, pretty cool problem. And I hope this explanation was useful. And yeah, I recommend this method of representing intervals where it's inclusive on the left and exclusive on the right, because it has these nice properties and some other nice properties. And I wonder if there was a simpler way to do this, because getting sort of this logic right is kind of complicated. But that's the way I did it, and it seems fun. See you tomorrow.